Hey everyone, this is 6.4 properties of rhombuses, triangles, and squares. What properties do we know from chapter 6.2 about parallelograms? Well, the first thing that we should have learned is that opposite sides are congruent. Okay. The second thing we should have learned is that opposite angles are congruent. Okay. Then we learned that consecutive angles, meaning angles that are next to each other, okay? So those are called consecutive angles, are supplementary. And what does supplementary mean? That they add up to 180 degrees. Okay, then aside from all the sides and the angles, there was one more rule, and that rule was that the diagonals of a parallelogram bisect each other, meaning the lines on the diagonal get cut in half. Okay, so make sure you write these down. Today's lesson revolves around special types of parallelograms, okay? So there's 3 words that are missing, and we're gonna fill those in. So a rhombus, okay, make sure you fill that in. A rhombus is a parallelogram with 4 congruent sides. Notice 1, 2, 3, 4 congruent sides. A rectangle, make sure you fill in rectangle. Okay, is a parallelogram with 4 right angles. So if it's got 4 right angles and it's a parallelogram, it is considered a rectangle. A square is a parallelogram with 4 congruent sides and 4 right angles. So if you notice, a square is both a rhombus and a rectangle. Okay, because we have 4 congruent sides and 4 right angles for both a square. So, is parallelogram ABCD a rhombus, a rectangle, or a square? Explain. Well, if you notice, this is a parallelogram, okay? And what that means is that opposite angles are congruent. And they already gave us that one angle is 90 degrees. Which means another angle is 90 degrees, which means all 4 angles are 90 degrees. So parallelogram ABCD has 4 right angles. Okay, since it has 4 right angles, parallelogram ABCD is 4 right angles, a rectangle. Is EFGH a rhombus, a rectangle, or a square? Explain. Well, if we look at EFGH, that's the one in the middle, right here. And what they're showing in this picture is that they have this side and this side are the same. Okay. Well, what that means in a parallelogram is that these sides must also be the same. So if parallelogram EFGH has 4 congruent sides, so parallelogram EFGH is a 4 congruent sides, right here, is a rhombus. All right, a couple theorems here. This should be gone. I don't know why this is in here. If a parallelogram is a rhombus, then its diagonals are perpendicular. Make sure you fill in are perpendicular. Fill in the highlighted yellow words. Okay, since it is a rhombus, all four sides are the same, then AC is perpendicular to BD. I'm just going to make a note that this symbol means perpendicular. And what does perpendicular mean? It creates right angles. And that right angle is shown right here with the box. Okay. Theorem 6-14. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Okay. So we have your rhombus in the middle picture, and if I draw my diagonals here and here, then we're going to say that there's a bunch of different angles that are congruent. As you can see, I'm labeling them. Okay, those angles would be angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, angle 5 is congruent to angle 6, angle 7 is congruent to angle 8. So make sure you fill in your highlighted words and you fill these angles in that are congruent, because these are the rules that you're going to need to remember. What are the measures of the numbered angles in rhombus A, B, C, and D? So we have all these different angles. The first one they give us is 58. So since angle, that little piece is 58 according to this last rule, angle 1 and angle 2 should be congruent, right? Which we see here. So if I go back, that means that this little side is also 58 degrees. Okay, then remember, we had this thing called alternate interior angles. So if this is 58, then angle 3 needs to be 58. Okay, so that's the first one I'm going to write, is angle 3 equals 58 degrees. And that's because of alternate interior angles. Then I can look and say that, well, this 58 is alternate interior to angle 2. So angle 2 also equals 58 degrees. And that's because alternate interior angles are congruent. Okay, now there was a rule that we just wrote down, 6-13. If a parallelogram is a rhombus, then its diagonals are perpendicular. Well, that means that all four of the angles in the center are 90 degrees. Okay, and if I look at our image here, we have angle 1 in the center. Angle 1 is going to be 90 degrees. And that theorem was called Theorem 6-13. Now, the only one that we're going to have trouble finding is angle 4. But if you notice, let me erase this to make it a little clearer. This is a little triangle here. Triangles add up to 180 degrees. So angle 1 plus angle 3 plus angle 4 equals 180. Well, we already know angle 1 is 90, angle 3 is 58, and angle 4 is the one we're trying to solve for. So angle 4 plus 90 and 58 makes 148 degrees. Minus 148 on both sides. And angle 4 is equal to 180 minus 48, which is 32 degrees. All right, so now you've solved for all four of the missing angles in the given rhombus. Your last theorem for today is if a parallelogram is a rectangle, then its diagonals are congruent. Remember, it's only a rectangle if it has four right angles. Okay? So the diagonals then are congruent. And what does that mean? That the entire line of AC, this entire line, is congruent to the entire line of BD. So AC is congruent to BD. All right, a little practice with this. We have rectangle RSBF shown in the top right corner. SF equals 2x plus 15. So SF is one diagonal, and RB is 5x minus 12, which is your other diagonal. It says, what is the length of the diagonals? Well, we're going to set them equal to each other. So 2x plus 15 equals 5x minus 12. You have an x on the left-hand side, an x on the right-hand side. I always suggest to move the smaller one. So this is a positive 2x. I'm going to subtract it. 15 equals 5x minus 2x is 3x minus 12. We're going to add 12s to both sides, and 27 equals 3x. Divide by 3, and x equals 9. Now, that's not what they asked for. They asked for the length of a diagonal. So I'm going to plug that 9 in to one of these two equations. Okay, I'm going to plug it in for SF equals 2. Instead of x, we're going to use 9 because we just solved for x, plus 15. SF equals 18 plus 15, okay, which is 33. Just to double check with RB, RB equals 5x minus 12. Well, this is really 5 times 9 minus 12, which is 45 minus 12, which is 33. So it works out because both are the same. Okay. Here's your exit slip today. We have LN is your one diagonal and MO is your second diagonal. Set these two equations equal to each other to solve for x. Okay, so 4x minus 17 equals 2x plus 13. Subtract both sides by 2x. And 4x minus 2x equals 2x minus 17 equals 13. Why don't you continue to solve from here? Add 17 to both sides. Okay. And solve for x. Once you solve for x, plug it in to one of these two equations.